As reported by Richard Rennie in this week's New Thinking in Farmers Weekly, it's following on from the Climate Change Commission's recommendations that farmers probably face the prospect of reducing their stocking rates to meet carbon reduction obligations. But the head of the nation's largest seed bank is urging, well, hang on a minute, we may be sitting on the answers, mining into our seed banks to find that gold, which could be lowering methane emissions. Looking into this article, I have to highlight this extremely interesting fact. There are more than 300,000 species of flowering plants on the planet. Only 120 are cultivated, and 9 account for 75% of global plant-derived energy. Only 3, wheat, rice and maize alone, account for more than 50%. So it's understandable that a group of 37 science institutes around the world are calling for greater crop biodiversity to contend with climate change, pestilence and disease outbreak. Joining us now from the Margot Forde Germplasm Centre is Director Dr. Kioumars Ghamkhar to talk about this. Kioumars, it's incredible the collection that we're sitting on here in New Zealand, the largest repository in the world of forage seeds, 150,000 seed samples. Could you please let us know, where on earth did we end up with only commercialising such a small variety of our forages?
Well, thank you very much for the opportunity, and that's a very good question that I always keep asking. But the main reason is that the human beings and us as human beings really in the history have tried to basically adapt everything to what we want. And the first thing that we found among the crops, whether it was the perfect crop or it wasn't, and we manipulated it, by very traditional and ancient breeding methods or improvement methods. What we did was that just worked on them and changed them and then adapted to the situation or conditions that we wanted. And then we generalized those, if you like, improved lines to different regions, which is not exactly what the nature of plants are, because the plants have microevolutions in micro-regions, climatic regions. But, we develop wheat, for example. Of course, there are many cultivars of wheat for different environments, but there are some other species that have very narrow genetic diversity, and they use across the board everywhere, which is not the way that we should do agriculture, in fact.
I mean, you just look at the vulnerability of when the PSA outbreak hit our kiwi fruit. And I mean, perennial ryegrass, our main crop in New Zealand, is derived from such a small genetic pool. What risks are we at of this monocultured future if we don't delve into the incredible seed bank that we have at our fingertips?
Well, the fact is that we have a very good biosecurity system, even in New Zealand specifically, and also across the border in Australia. But the fact is that we can't be perfect, and things can get out of control. If we get the pest or disease inside the country, and it targets ryegrass, and it goes out of control very fast, then we don't probably have the genetic diversity to resist that pest or disease. Or, if we explore the germplasm or genetic resources at the gene bank, there's this collection of seed that we have about 3,000, populations of wild ryegrass and its relatives. If we explore that, we can find it possibly, or at least guess where they are based on their data, not guess, more than guess really, and find that using genomic phenotyping tools, etc., then we'll be able and prepared to fight that and avoid the disaster. But if we keep waiting until the disaster hits, then it's too late. That's what we're saying. With old crops, I call ryegrass old, it's not really ancient like wheat, but with old crops, the ones that are settled, and we use them across the board in the country, we should have that diversity. Studies have shown genetic diversity doesn't really exist as such in the gene pool of cultivated ryegrass. So we should diversify. And of course, that's one side of it. The other side is other species. the number of species that we use is very limited as well.
You're an active member of DivSeek International Network, Kioumars, and it's really interesting how there's so many different examples of, heat-tolerant plants, a lot of trials in low methane emitting plants as well that we could be looking to. And there's one particular you highlighted in the Farmers Weekly article that is from the Northeast Africa, a legume.
Yep, that's called Bicerula, and Bicerula is, a legume forage species, forage legume. There's just got one species. So in terms of the risk of interspecific hybridization, naturally it's very low. It's almost non-existent. So it's not a risk from the point of view of crossing with other species if we import it. I'm not saying that it will be perfect for New Zealand, but it can be, the germplasm can be investigated. There are about 200 wild populations from specifically Eritrea, Ethiopia, and the Mediterranean in Italy and its islands, islands around Italy. So basically, there is a diversity there. What is interesting about that forage species is that I worked on it before in Australia, in Western Australia, in fact, and when we did, we identified the fact that it reduces methane. Of course, our experiments were small scale, but we did test it in live animals, in both sheep and cattle. But we didn't go larger scale because it was a student work mainly, a student of mine, and we didn't have a lot of budget to go and look at it. But when we compared that with 14 other species, forage species, mainstream species such as clover, ryegrass, etc., it reduced methane by about 30 to 40%. So that's a lot. I'm not saying that it definitely be repeated here if we do it in larger scale, but what is causing that? We also shown that there are some metabolites that might be causing that. Can we use those metabolites, if not the forage? Can we use those metabolites to reduce the methane emissions from animals? So what I'm suggesting is that let's look at this gold mine that we have as genetic resources, as germplasm, to see what we can do for the future to adapt. I know the government and the public want change, and we have to embrace that, and we will, as usual. But we have other things to look at as well, as like reducing the stockings. That's good and fine, should be done. But also, have we provided, or are we ready to provide the material and tools to farmers to actually measure these things? Measure, how much methane is produced in their farms, say in real time, and also look at the germplasm, the material that can actually, maybe they don't need to dramatically reduce the number of animals, but they can reduce the methane footprint still using a different forage. It's not going to happen overnight, but if we do this, who knows what happens in the next 4 to 5 to 10 years? Maybe we can help them a lot.
There's been a lot of suggestions that the technology is not here, genetically edited ryegrass, methane inhibitors, etc. But are you suggesting that we are sitting on a huge gene bank of species that are ready to go, and a lot of neglected species have come under fire of lack of science funding and being able to commercialise them in an environment that's led to where we are?
Yeah, well, I wouldn't say they come under fire, but the fact is that they haven't been supported. Let's put it that way. There are species such as subterranean clover, and we have people in, say, Lincoln University and across the country that are working on subterranean clover. There are farmers who are growing it, but it's not larger scale as such. It's not really, if your white clover is not growing in the eastern, the eastern hill country of North Island, you don't have to grow it there. If it hasn't got deep roots, then maybe subterranean clover is a better option. It's not a new debate between scientists. There are a few scientists who are working on these things and a few pioneering farmers who want change and adaptation to their environments. But where is the larger scale experiments and works, or some big support by the government to actually direct us to this to this direction, if you like, and basically help us go and say test a subset of subterranean clover collection in different environments and see which one adapts to our environment better and grows better and produces yields better. We haven't done any of that. There is some work, but it's very limited, very really not in a coordinated way, really, just personal interests by some scientists.
It's absolutely outstanding, the work that the Margot Forde Germplasm Centre do, and thank you very much, Dr. Kioumars Ghamkhar, for all of the work that your team do in protecting our such large varieties of species, some 2,200 species with 2,500 wild variations alone of white clover. So therefore, we may be sitting on the gold mine, and in the article that Richard Rennie's pulled together, Kioumars suggests that he feels like a bit of a gold prospector at the moment, searching for those solutions. And of course, you can read all the further article and the details in the link of this episode below, as well as, of course, at farmersweekly.co.nz.